Hello everyone, my name is Aniket Sayoke. So today's topic, my presentation is Introduction to RNN, Need of RNN, Types of RNN, and Sentiment Analysis with RNN. Now we will see why we use RNN. Many tasks like speech, text, and time-based data depend on the order of input. A normal network looks at every input alone, so it cannot link one step with the next. Because of this, it fails to keep context, like missing the meaning of a sentence or change in a voice tone. So we need a model that can hold past details and use them for the next step. That is why we use RNN, a network made to handle data flow in a sequence, just like human thinking. Now let's see what RNN actually is. It is a special type of deep learning model that can work with data that comes in a sequence like text, speech, or time-based input. Unlike a normal network that forgets what came before, this model keeps a hidden state, a small memory that saves key detail from the past and uses them in the next step. It can handle data of any length, keep short-term time memory, and use context to make better output. Just like how we understand a sentence by recalling earlier words. This model also learns meaning by remembering what we came before. Now let's understand how an RNN works. When data comes step by step, this model takes one input at a time, like one word in a sentence. At each step, it keeps a hidden memory which stores key detail from the last step. Then it combines this memory with the new input to make the next output. This process goes on the full data sequence, passing useful details ahead each time. During learning, the model goes back in the time and updates its weights. This method is called backpropagation through time. In simple words, an RNN learns by linking past, present, and next parts of data, helping it make smooth and context-based output. Now let's see the main types of RNN. First we have the simple RNN. It is the basic form that can handle sequence data but keeps only short memory, so it forgets things that happened long time ago. Second one is the LSTM, which means long short-term memory. It fixes the memory loss issue by using gates that decide what to keep and what to forget. Then the third one is GRU, a gated unit. It works like LSTM, but it is faster and has fewer parts, making it easy to train. And the last one is bidirectional model. It reads data in both forward and backward ways, giving a full sense of context. This type makes sequence learning more effective for text, sound, and time-based data. Now let's see how an RNN helps in sentiment analysis. It helps a system understand human emotion from text. Like if a comment is happy, sad, or angry, this is used in social media, product feedback, and customer opinion study. In these tasks, text is first changed into numbers called word embeddings. Then the RNN reads each word one by one, keeping the link between old and new words. At the end, it gives the final mood of the full line, positive, negative, or neutral. For example, the movie was really good, gives a positive feeling, while the service was slow and bad, gives a negative one. This way, the model learns emotion just like we do, using context and memory. Now let's talk about some limits of RNN. When we train on long data sequences, the signal that helps the model learn can become too small or too big. This is called the vanishing or exploding gradient issue. Because of this, the model often forgets early details in the data. Also, RNN find it hard to link events that happen far apart, making them weak for long patterns. They are also slow to train as they work one step at a time instead of all at once. Along with that, they need high memory and power and can overfit small data, meaning they learn exact samples instead of general patterns. That's why improved models like LSTM and GRU was created to fix these limits. To sum up, RNN are smart deep learning idea made to handle that comes in a sequence like speech, text, or time-based input. They can keep memory of past input, helping them find meaning and flow in data. These models are used in many AI systems, from voice and text emotion study to medical and face-based analysis. Even with limits, they stay an important base for models like LSTM and GRU, which improve memory and speed. In short, RNN help machine think in order, just like how humans connect one thought to the next. Thank you.